Hello world and welcome to this edition of Tech on Fire with Blaize. I'm Blaize Stewart, an architect at Winelect, and today we're going to be going over the VM series available on Microsoft Azure. On Azure, there are several series of VMs that are organized around the kind of workload that would be typically used by a given series of VMs. Now, within that series, you have a lot of variability. You have everything from small options to humongous options, but it's really understanding what the intent behind a given series of VMs is that will let you choose what the appropriate VM for your application when you go to deploy that application on Azure. The first VM series I want to talk about are the A-series VMs, and I chose the moniker Alpha to represent this because they are really intended for things like test, development, and POC kind of work, but are not really intended for production level workloads. So you would want to select these if you're doing like a lot of those small kind of one-off workloads, and you just want a quick VM to spin it up on that's not going to cost you a fortune to use. You can select the A-series for that. On top of the A series is the B series. Now the B series are a general purpose VM, but they are a special kind of VM because of what they do, and that's bursting, and that's why we selected Bustable for the moniker here. The way these work is you have a CPU baseline that is a typical threshold for what that CPU is going to be working at for the life of that VM. So think about a VM that is idle most of the time. Its threshold on that CPU might be at 1 or 2%, or maybe it's 5%. And then that's the typical average for that given VM most of the time. But on occasion, you'll need more than what that threshold is, and you will need to burst that CPU. And so what Azure does is while your application and while your virtual machine is sitting in that more idle state, you're accruing credits that will allow you at some point while you're running that VM to burst it to get a much higher percentage of the CPU than what it was at its baseline configuration. So imagine if you're running an VM and it's most of the time sitting around, say, 10%, and you accrue credit, and then all of a sudden you get a lot of work thrown at that VM. It will burst that up to maybe 100% or 200% of that baseline, and then it will use the credits that you've accrued in order to burst that VM. So these are also very economical because you're paying for generally a fraction of a CPU rather than the full CPU. So you can have better VM density. So Microsoft is able to work down the price for these VMs, and so you can use them at a more economical rate than, say, what you would be paying for full capacity on some of these other series we're going to mention. The third one I want to mention are the D series the D series and the DS series. These have gone through a lot of different versions. So you have version 1, 2, and 3 out, and the D series is probably the most popular option for VMs on Azure because these are general purpose VMs. They're well-rounded VMs. They have a fairly decent CPU to RAM ratio, usually about a 2-to-1 ratio, 2 gigs of RAM for every 1 core. They have decent IOP performance. They have decent network throughput and all of these things. So they're well-rounded VMs. And if you go into the Azure portal and you create a virtual machine, more than likely it's going to default to one of these D-series VMs. And the reason why is because they don't really intend to know what you're planning on using the virtual machine for. So they'll default to these D-series for that reason. And as a general rule of thumb, you can do the same thing. If you're not sure which one to select for your given application, pick a D-series VM to start with, and if you see that it's the CPU is struggling to keep up with the workload, then you can go with a CPU optimized VM. Or if you see you're using all the RAM on that, but your CPU is sitting idle a lot of the time, then you can go with a memory optimized VM or something along those lines. And we're going to talk about some of these more special case VMs following. the next one, which would be the DC series VMs, which are just D series, but there's a special case of the D series VMs because the DC series are I call D-Crypt VMs because these are VMs that have a higher level of security baked around them, and so they're generally intended for workloads that need to be more isolated in the Azure ecosystem than the other VMs that are running on Azure. So they're essentially D-series VMs with better security baked onto them. So select those for sometimes if you need a VM that has a lot of sensitive data running in it. The next one that I want to mention are memory optimized VMs, and these the moniker I chose for this is Engrams because I couldn't think of anything dealing with memory other than that word. So Engrams is the moniker I opted for to generally dealing with memory, which Engrams were some kind of memory implant or something like that. Anyways, a memory optimized VM is typically going to have a higher RAM to CPU ratio than, let's say, a D series VMs or other VMs on Azure. And so if your application needs a lot of RAM to run but doesn't need a lot of CPU, this would be a good option to choose from. Now, kind of on the flip side of the E series are the F series, and the moniker I chose for this is FLOP. So if you know, stands for floating point operations per second. So you're going to get more flops out of a VM that has more cores on it. So because it can do more calculations per second or floating point operations per second in that given VM. So if you need a lot of CPU, but you don't need a lot of RAM, the F series would be a good option for CPU intense workloads. But there's also the G series that are also memory optimized VMs, but they're also storage optimized VMs. So if you have something that is like a analytics workload that needs in-memory data or that needs data access at a high IOPS or combination thereof, these VMs are going to be very useful for that kind of analytic workload, and that's kind of what they're intended for. And I chose gigabytes for this because you can have a lot of gigabytes of RAM, a lot of gigabytes of storage in these G series VMs, and some people call them gigantic VMs because they typically have a lot of storage and a lot of RAM attached to them relative to the number of cores that are available in that given VM. Now, the other one that's related to this would be the H series, and this is your high performance computing. So that's the moniker for it. It's HPC, and the typical use case for these HPC VMs is, as I mentioned, high performance computing, which is typically where you have a cluster of these things that are being delegated work from some kind of centralized management of the workload. So you create a cluster of these H series VMs, and then each one of them is going to run a portion of that work and then report that result back to the master node so that it can combine that work to create a work set that is produced for whatever the application might be. But in any case, these are typically going to be using analytics or rendering workloads, a lot of other things that are related to anything that requires a lot of CPU and just constantly crunching lots and lots of data over a period of time. So that's really what these HPC VMs are intended for. On top of the HPC ones are another special series of VMs, and these are the LS VMs. LS stands for local storage. Now, every other VM series on Azure will have the storage stored on some other storage device that's not physically located close to the RAM and CPU. And this is typical of a data center where you have a storage device that's like a network attached storage or a SAN, a storage area network that is connected by some kind of fiber channel, and it's really where all the storage is hosted, and the CPU and RAM then connect to that over some kind of high-speed backbone. Now, with these local storage VMs, the storage isn't on that SAN or NAS device. It's rather on the same physical hardware as the CPU and RAM. So it's located physically very close to the CPU and RAM. So you get really, really, really low latency between the RAM, the CPU, and the storage on these VMs. Now, the intended workload for these local storage VMs is when you have an application that has that needs a lot of IOPS to run, so a lot of input output per second, and this is typically true of database applications that are processing a lot of small transactions. And small transactions typically require a lot of input outputs per second. And then sometimes if you're accessing a lot of small files, that can also be a use case for these kinds of VMs as well, where you have a lot of small files that you got to read and write to on a local storage. And having that high IOPS is really going to pay off whenever you have that kind of workload. If it's just throughput that you need, then these aren't necessarily going to be the best choice. Throughput is, that's something like just streaming a large file across that backbone connected to a NAS. You're not going to see a huge performance gain by using an LS series versus some other VM. But if you have to read and write a lot of read and writes on the disk, then the L series is definitely going to be your friend for those kinds of workloads. Now, on top of the L series VMs, there is the M series, and these are memory optimized VMs, but they have just a ginormous amount of memory. And these are called monster VMs because of that. And these are really intended for in-memory databases that are typically big data type workloads. So if you can imagine something like Apache Spark, which would be have an in-memory database, and it's doing all kinds of crunching against that in-memory database rather than doing it off the disk. And these kinds of workloads are really the intent behind the M series. But these are also very expensive VMs, so be cautious whenever you go to spin these up, because while they have a lot of RAM in them, they're also going to cost a lot of money. And that's why they call them monster VMs. Now, you probably want to test with some of the other more modest memory optimized VMs like the E series or the G series before going to something like the M series. But if you need that scale, then it is available on Azure in the M series. And the last one is another special case VM, and this is the N series. The M series uses nVidia cores on the hardware as well. So you have available to you the ability to run GPU workloads on Azure. And so Microsoft has created the N series for that. So if you have something like video rendering that takes advantage of GPUs, that would be one workload for these N series. Or some AI workloads take advantage of the just sheer number of cores that a GPU has over something like a traditional CPU. And so AI is one of those things that can take advantage of them. Like Bitcoin mining can be done on these as well. But anything that needs to take advantage of the sheer number of cores that a GPU has, then you have that available on Azure through the N series VMs. So this basically is the summary of all the various VMs on Azure. So you have a lot to choose from. Now, I would encourage you to go out there and explore the various VM sizes on Azure so you can get a better feel for what these are. And then once you have you can check out the cost of them and then see how they relate to one another. And then start deploying some of them on Azure just to kind of get a feel for how they perform. And then take your given application, say throw it into a D series, and then test it out, see what it looks like on a D series, and then fine tune it by selecting something from another series for your application if you need it. Otherwise, or you can just keep it in the D series, or maybe you can put it to a B series and get cost savings if it doesn't take full advantage of everything that D series has to offer. Needless to say, you have a lot of options to choose from, and having these options will help you not either have the workload perform very well on Azure, or a way to reduce the cost of running your application on Azure, depending on which way you go, scale down, scale up, whatever, but you have the options. And that's the main thing to take away from this, is knowing your options and then being able to choose the appropriate option for your workload. If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.